Hi, welcome to Louisdale, home to glutamate, tryptophan, serotonin, GABA, epinephrine, tyramine, dopamine, acetylcholine, glycine, norepinephrine, substance P, and metenkephalin. Disclaimer, Louisdale is not a real town and no neurotransmitters were harmed in the making of this video. Who are Louis and Dale? They're two major greats in neurotransmitter history. They discovered acetylcholine and together won the Nobel Prize in 1936. What is a neurotransmitter? Neurotransmitters are molecules that are synthesized in and released from the presynaptic neuron and act on receptors located on the postsynaptic membrane. The presynaptic neuron must depolarize in a calcium-dependent manner in order to release these neurotransmitters as a package or synaptic vesicle. How are neurotransmitters classified? We thought you'd never ask. There are several ways of classifying neurotransmitters. Some are very specific. For now, we'll group neurotransmitters as biogenic amines or monoamines, amino acids, which include inhibitory and excitatory substances, neuropeptides, and acetylcholine, which is sort of off by itself. Each of these groups can be broken down even farther, but for now, let's think of each of these categories as a neighborhood in Louisdale. How and where do neurotransmitters work? All signals within the body are transmitted on neuron highways. The neurons are made up of a cell body or soma, dendrites, and the nerve fiber or axon. At the end of the axon lies a community called Louisdale in the presynaptic terminal. The synaptic cleft is the park that the neurotransmitters must cross to meet their respective receptors on the other side of town. Their interaction with the receptors causes action potentials to be transmitted to their sites of action. Neurotransmitters live in vesicles or houses within the axon terminal. When an action potential is transmitted down the axon terminal, it stimulates the release of calcium from the membrane of the presynaptic terminal. Stimulated by calcium, the neurotransmitters are released by exocytosis. They now come out of their houses to play. Into synaptic cleft park they go to attach to their respective receptors at their sites of action. The activation of these receptors cause either hyperpolarization, making the cell more negative, or depolarization, making the cell more positive. Depolarization is called an excitatory response, and hyperpolarization causes an inhibitory response. Some neurotransmitters, such as the amino acids, are either inhibitory or excitatory. Some neurotransmitters have the ability to be either depending on the receptor they attach to. Once the neurotransmitter is released from the receptor, they are inactivated either by enzymes or by reuptake into the presynaptic vesicle. Dopamine, norepinephrine, and epinephrine are part of the catecholamine family. They are synthesized in the body starting with the ingestion of phenylalanine found in protein-rich foods such as meat, fish, eggs, cheese, and milk. With the interaction of the enzyme tyrosine hydroxylase, phenylalanine converts to tyrosine and then to L-DOPA. DOPA decarboxylase converts L-DOPA to dopamine, and dopamine beta hydroxylase converts dopamine to norepinephrine. Through methylation, norepinephrine is converted to epinephrine. The catecholamines like to stay in their special houses called chromaffin vesicles before it is time for them to socialize. The chromaffin vesicles are located on Amine Boulevard, which you'll see in Part 2.